Okay, so next example is the Persian Gulf. Persian Gulf. Okay. So we discussed the Red Sea. Here's the Persian Gulf. The top figure shows you the bathymetry, the depth, and have a look at the numbers. Maybe hard to see here: 20 meters, 40 meters, 80 meters. And then you have the Strait of Hormuz, which is the connection to the Gulf of Oman and the northern Indian Ocean. Maybe 80 meters in there. So it's totally different compared with the Red Sea. It's shallow. Okay, this is what we call an inverse estuary. Okay, it's something semi-enclosed basin, a limited connection to the ambient ocean, and the circulation is mainly driven by density. Okay, and in these inverse estuaries, where these are hypersaline systems, because you have on average per year, you lose more water to evaporation than you gain through continental runoff and direct precipitation. Salinity gives you clues on the circulation. And this is what's shown here in these graphs. It's derived from a computer simulation, but anyway, so this is very, very close to the observations that you have. So let's have a look at the circulation. Let's see what happens near the bottom. And you can see here in this structure, it's a little bit hard to read the numbers here, but essentially red means hypersaline with values up to 50, okay, 50 grams per liter of salt. And yellow is still 10 units above the typical ocean salinity. And ocean salinities, then you end up here with 35, 36 ambient. You know, this is what you find. So the entire region is hypersaline, but you can see certain regions which stand out, which contain the saltiest water, okay, which is here near Saudi Arabia, okay. And, you know, you have very saline water here. And you can also identify an outflow of essentially the green-yellow stuff here is the outflow near the bottom. And it takes place, say, on the southern side. And this is because of the Coriolis force. The Coriolis force, the Earth rotation pushes the outflow over to one side of the Gulf. And you can identify the return flow near the surface. Okay, you can see the tongue of low salinity water, lower salinity water, the blue water. And it moves along the surface, along most of the Gulf. And another region where you have low salinities are actually river. That's the river discharge from 3 rivers that you have here on the northern end, creating something that we call a river plume. Its surface features low salinity water, keeps it near the surface, moves along one side of the Gulf because of the Coriolis force. Okay, this is an example of Persian Gulf. Let's just have a look how the exchange looks like now with the ambient ocean. I think it's shown here on the next slide. The Persian Gulf outflow. Again, you find this figure here in the Tomczyk Godfrey textbook that you can download. Okay, 3 panels. The top panel is temperature. The middle panel is salinity. The lowest panel is dissolved oxygen. Okay. Middle panel, you can see the outflow of hypersaline water. Okay, you can see in the ambient Indian Ocean it's 36, near the surface. This one is just marginally higher salinity, and it creates a signature as something like 100, 200 meter depth. So it doesn't sink as deep as the outflow that comes from the Red Sea. Okay, and it does not, although the water has a little bit higher because of interaction with the atmosphere, has a higher dissolved oxygen content, it does not increase the outflow. It doesn't carry enough volume to increase the oxygen levels in the adjacent Indian Ocean. Okay, and the units are milliliters per liter. Look how low dissolved oxygen levels are here within the upper 2 kilometers, except for a thin layer near the surface. This is an absolute dead zone. Okay. All right, so you learn quite a bit. Okay, what else is there? What else is there about the Indian Ocean?